Alright, let's get on to a little bit more about the unit circle. So, our unit circle is a circle on our x and y axis, and it's centered around the origin, so it's right in the middle, and our circle has a radius of 1. So what this means is that looking at our circle, every time it intercepts an axis, it's 1 unit away. So as you can see here, right here, this point has an x value of 1 because it's gone 1 across, and a y value of 0 because it's an x-intercept. Up here, it has an x value of 0 but a y value of 1, and so forth. So, what we now need to think about is the rotation. So, when we're thinking about a unit circle and an angle within a unit circle, we actually start with the positive x-axis. So we start on this line here, and we're going to move anti-clockwise around in this direction, right? So, the rotation can be measured in degrees or radians. If I were to measure, say, 45 degrees or pi on 4, I would start at the positive x-axis, and I would move this direction by 45 degrees, and this would give us 45 degrees on the unit circle. Alright. Our unit circle also has a Cartesian equation, which is a term you might not have heard before. What this essentially means is that we have an equation that we can actually graph the unit circle with, right? So, what you've seen so far is graphs such as parabolas, linear lines, maybe cubics, stuff like that, right? But you can actually graph circles. So circles aren't technically functions, but they are relations. If you're unfamiliar with that terminology, have a look back to the beginning of Unit 1 when you're looking at kind of functions and like the vertical line test and all that kind of stuff. Obviously, a graph is only a function if it passes the vertical line test, however a circle doesn't. So it's just a relation, but that's okay. So our unit circle has the Cartesian equation x squared plus y squared equals 1. So if you wanted to model the unit circle, this is how you would do it. Alright, now let's get into how we can actually link the unit circle and sine and cos. And this is really where the majority of the use of the unit circle comes from. So, if we have a point on the unit circle, this point here, P, right, and this has an angle theta, right? So we started on the positive x-axis, we've moved anti-clockwise, we've got an angle theta lining up to a point on the unit circle. We have an x value and a y value. And of course, the length of our line between the origin and the edge of the circle is 1, because our unit circle has a radius of 1, and of course going from the middle to the edge is a radius, right? So, what we can actually see, or what you'll need to remember, is that the cos of theta is actually the x-coordinate of point P. So it's actually this pink distance here, or the x-coordinate of point P. And sine of theta actually represents the y-coordinate of point P, or this green distance here. And this might not seem like it makes a lot of sense at first, right? It kind of just seems a little bit like you're just kind of saying, well, this is cos and this is sine, and that's just how it is, right? But I'll actually explain why it makes sense, and it might be a little bit of a wow moment for you. So, have a think about this. Cos theta, right, is equal to the adjacent over the hypotenuse, right? So if we have theta here, our adjacent is this pink x line, and our hypotenuse is 1. So our cos of theta is actually just equal to our adjacent over 1, which is just equal to our adjacent, which is x. Similarly, for sine, this is equal to the opposite over the hypotenuse. So the opposite of theta is this green y value, and the hypotenuse is 1. So our sine is equal to y on 1, or just y, right? So this is where we actually get these definitions from. It's just by using our very basic trig ratios, right? So now let's get into the unit circle definition of tan theta, and this one is a little bit more complicated. So tan theta is actually equal to sine over cos, right? So have a think about this. Tan usually is equal to the opposite over the adjacent, right? If we're thinking about theta, the opposite of y, so the opposite is y, and the adjacent is x. So what we actually have is tan theta being equal to y over x. Remember though, y is equal to sine theta, and x is equal to cos theta, right? So we actually have a special unit circle definition for tan as well. Alright, now let's get into the domain and range of the unit circle. So, the domain of the unit circle is between -1 and 1, and the range is in between -1 and 1. And of course that's because the radius of the unit circle is 1, so on either side, the x side, it's going to be between -1 and 1. On the y side, it's going to be between -1 and 1. But now we need to ask ourselves, what is the range of sine and cos as functions? Right? So, because sine and cos are the y and x values respectively, and our y and x values are between -1 and 1, it means that they have the same domains. And, sorry, they have the same range, right? Because this is essentially x, and this is essentially y. So we can just swap these out. X for cos theta and y for sine theta. So, this tells us what values cos and sine must always fall between. Now, this is actually really important when you're getting into word questions. So, because we know that the range of sine and cos is between -1 and 1, if you're ever asked to find a maximum or minimum value, you can use this, right? We'll get into a few word questions using this information, but just make a note of this in your book or your laptop or wherever you're taking notes. If you want to, say you have the height of water being equal to 3 cos t, or something like that. Right, so this is getting into the applications. So the height of water is equal to 3 cos t, where t is time. Right, so say the water at a dock or something like that, the height of the water changes depending on the time. To find the maximum height, all you need to do is the maximum is going to occur when this is equal to 1, right? Because that's when the maximum is going to happen. Because cos of t is never going to be any bigger than 1, the biggest of this whole equation can ever be is when it's equal to 1. So our maximum is going to be 3. Then our minimum is going to be when this is equal to -1. Because the smallest this whole equation is going to be is when this is equal to -1. So our minimum is going to be -3, right? So that is just a simple application of this domain information, right? Make sure you write that down for when you get onto the applications, right? So, what is the domain of sine and cos? It can be anything, any real number at all, right? And this is because theta, when your angle, can be anything at all. You can have whatever angle you'd like. It can be positive, it can be negative, it can be -1,000,000, and that is still possible. Just in case you're confused, real number means anything you've ever dealt with in methods. If you're in specialist and you've gotten on to kind of imaginary complex numbers, right? Those are not included as a real number, but in methods, any number you've ever looked at is a real number. So don't worry about that. Okay, now we're getting on to domain and range of tan. So tan is a little bit strange, right? So tan's domain is not actually all real, as tan theta is not defined for a value of theta that is an odd multiple of pi on 2, right? Have a think about why this is. I'd like you guys to pause the recording, write down what you know so far, and have a think about why is tan not defined for a value of theta that is an odd multiple of pi on 2, right? Let's have a look. So, remember, tan is equal to sine on cos, right? When we're looking at our unit circle, and we're looking at pi on 2, this up here is pi on 2, right? So remember, we have 0, we have pi here, right? So pi is 180 degrees, and then coming all the way back around, this also gives us 2 pi, right? So at pi on 2, sine, remember, is our y value. So our y value up here is 1, because our unit circle has a radius of 1, so if it's going all the way up, it's going to have a y value of 1. Our x value is 0, right, because it's a y-intercept. Have a think about what issues we've come across so far. As you can see, we're dividing by 0. And in maths, we can't divide by 0. It gives us an error. If you try to type that into your calculator, it's not going to work. So as a general rule, anything you're ever going to come across in methods, you cannot divide by 0. So This is why we have this issue with the domain of tan theta. So, therefore, the domain of tan is plus or minus pi on 2, plus or minus 3 pi on 2, and so forth, and range of any real number.